Hello everyone, in this video we'll learn about context-free grammar conversion to context-free grammar to PDA conversion. Okay, let's see the steps. First of all, remember the PDA, whatever you're going to you're going to get finally after the conversion will have only one state, that is Q. Okay, it's just the name I've taken here, so it will have one state, and that I'm going to name it as Q. And then the initial symbol of CFG will be the initial symbol in the PDA. And the next step is list all the non-terminals and terminals, and for each non-terminal symbol add the following rule. Its corresponding rule you are supposed to add. Suppose you have for a non-terminal symbol A, you have a rule called A gives AB, then represent a PDA in this format. Q epsilon A, write this here. Okay, this A should go to this place, and then its RHS should come to this place. So Q epsilon A, Q comma AB. That is what you are supposed to do. Next, for each terminal symbols add the following rule. That is, for each non-terminal symbols, that's why I told initially to list all the non-terminals and terminal. For each terminal symbols you have to add the rule like this: Q comma A, which is equal to Q comma epsilon for every terminal symbol. Now let's consider one example. Example 1. Here I am going to consider one CFG defined by G equal to ETF that is, you know that any grammar G is represented as V sigma R comma S. V sigma R comma S. What is V? All the variables, that is non-terminals and terminals. Okay, from this list itself you are going to get ID, the terminals and non-terminal list. ID plus star, open parenthesis and closing parenthesis, and then close. Next we have the alphabet sigma, this input symbol, that is ID plus star, open bracket, close bracket. Next we have R, all the rules, and then the starting symbol. So what is R? Where R equal to E gives E plus T, E gives T, T gives T star F, T gives F, F gives parenthesis D, and then F gives ID. So now how to convert this to PDA? And whatever the approach what I am going to use here is a top-down approach for the construction of PDA. Let's see the answer now. As I said, first I know that PDA will have only one state Q, and the initial symbol of CFG will be initial symbol of PDA also. That is, initial symbol or a start symbol of this entire CFG is E, isn't it? So the start symbol of a PDA also will be E. Okay, so that's why that I can represent like this. So to show that the start symbol, so let me take one state P, and here this is, I said I'm going to begin with the PDA with the symbol only one state, that is Q. So epsilon and then E. and after that all the PDs, all the representation of rules. So from Q, where you go here. Okay, what is the first rule? So you know that the rules are given here. E gives E plus T, E T, T gives T R star F, T gives F, F gives parenthesis D, and then ID. So let me list the non-terminals and terminals. Non-terminals are all the symbols that comes on the RHS. So we have, and don't write the duplicates one, E, T and F. So whereas terminal, here also you can get from variables, you can get the non-terminals, and the remaining will be your terminals. So sigma also gives your terminal. So ID plus star open parenthesis and then closing parenthesis. Now for each rule I will write a PDA. For first rule, what's the format for a rule? I've already told that is Q epsilon. For the first rule, I'm going to write here E gives E plus T, Q epsilon, and the LHS contains E, comma, Q, comma, E plus T. Okay. For the next rule, again, Q epsilon, E. Then for the second rule, E gives T, I'm writing here Q, comma, T. So here you are supposed to write RHS, here you are supposed to write the LHS of a rule. The rest will be same. Next, third, Q gives epsilon, gives T, comma, Q, comma, T star F. Similarly, fourth one is Q, then epsilon, this is epsilon, and then T, comma, Q, comma, F. Similarly, the fifth rule would be Q, comma, epsilon, comma, F, comma, Q, comma, parenthesized E. Next, sixth one is Q, comma, epsilon, comma, F, comma, Q, comma, ID. Next, seventh rule. So for all the rules, isn't it? So I have built here PDAs, transitions. Next, seventh one, that is once you complete the transitions for all the rules, next you have to now build the transitions for the alphabet symbols, that is the terminal symbols. So first I'll be writing for ID, Q, comma, ID, comma, ID, comma, Q, comma, epsilon. So just you have to follow the rule whatever I have told in the beginning. 8, Q, comma, plus, comma, plus, comma, Q, comma, epsilon. Next, ninth one, Q, comma, star, comma, Q, comma, epsilon. Then 10th one, Q, comma, open parenthesis, comma, Q, comma, epsilon. The 11th one is Q, comma, closing parenthesis, comma, Q, comma, epsilon. This is what the PDA for the CFG. Okay. Once that is done, you can even verify this PDA by taking some input of the grammar. You know the grammar. Grammar says that it's of type expression. So let me take one simple expression. Okay. So if you know PDA, if you know the PDA transitions, okay. If you know PDA transition, then Finding the computation on input is easy. It is similar to how we have PDA in the graphical format, graphical or a transition diagram format, state diagram format, and performing the computation. It's same as that. So that's why you start from the start state. Start state, here we have only one state, that is in the PDA, that is Q, and then you have to write input, okay. Input, let me take it as ID plus ID. Let me take a simple one, and then the stack symbol here initially will contain the start symbol. Stack symbol initially will contain the start symbol of the grammar, and as I said, start symbol of the PDA also is E. Okay. So next, so here you know that the rules for E, you're going to get what? EDA, isn't it? So first of all, Q, comma ID plus ID, ID plus ID, comma E plus T, plus E plus T. Okay. Next, this will be similar to the derivation. This will be similar to the derivation. So Q, comma ID plus ID, and then now E can be changed to T. So now your pointer will be at this place. So Q on E, what it is going to do? Q on E, there are two possibilities, either E plus T or E T, but I want to match with ID plus ID, so preferably I go with E gives T, T plus T. Next I will get Q, comma ID plus ID. Now again T plus T. So here the pointer is at this place, T gives F. Okay, T can give you two symbols. One is T gives F and is T gives T star F. So which one I will prefer? This one, because I finally this portion should become ID, because you know that there is only one plus here. So whatever comes before plus need to be ID. So that's why, so preferably the good selection for T is T gives F. So T gives F, so T will be replaced by F, F plus T. So you can look at the rule and do the same thing. Next, Q, comma ID, comma ID. Next, F can give you ID. F can give you on input Q, F can give you ID, right? So here it is ID plus ID, ID plus ID. So F can give you ID plus T. What happens finally? So now you can check that the input first part, isn't it, one symbol is matches with the other symbol. ID matches with the ID. So what we can do, this can be removed from the input as well as stack. So Q, comma, so this is comma, okay, Q, comma ID plus ID. So Q, comma plus ID, comma plus T. Now again plus plus is going to match at this point. Plus is also matching, so we can remove that from the input as well from the stack. So ID, comma IT, T, that is only remaining. So finally Q, comma ID, comma T can give you, what's the better rule for T? There are two rules. Finally we want this portion need to be converted to ID. So that's why better take the fourth rule. So T will be replaced by F, then Q, comma ID, comma F now will be replaced by ID, because we want to get ID. So we can see that ID and ID also will be matched finally. q comma epsilon. So your input is also empty. So this is how the computation is will be done. We can do on the input, any input, id plus id. Computation on input, id comma id is also done. This is the CFJ conversion, CFG to PDA conversion. Okay, and these are the rules whatever I have followed. You can observe here q comma epsilon a will be replaced by ab. This is how the non-terminal symbol will be replaced, and this is how the for each non-terminal symbols you can write the rule. Okay, this need to be comma. Next we'll see one more example for a CFG to PDA conversion. Example 2. Convert the following CFG to PDA. S gives A, B, B or A, or A. A gives A, B, B. And remember here, the whatever the rule I have taken is in this rule are in the form of Gray-Bash normal form. Okay, B gives B, B, and then A, then A. C gives A. Now our aim is to convert CFG to PDA. First of all, let us list the non-terminal symbols, that is S, A, B and C, and the terminal symbols are only A and B. A and B. How do you find the terminal symbols? Go to the RHS part of the each rule. Leave the non-terminal symbols. Leave these symbols. Whatever you are getting, other than the non-terminal symbols, other than the epsilon symbol, the remaining ones are the terminal symbols. So here, if you observe this part of the RHS, here you have ABB. What is remaining? A. So you add it in the T. That is to the set terminal. Next, here also we have A. So no need to write twice. Then when it comes to here, again A. The rest is non-terminal. It's already in the non-terminal. Next, you have A. No need to write it again. Next, here we get one more symbol, that is B, that I added here. Next, remaining are non-terminal. Here non-terminal. Here which is already added. So only two terminal symbols we have here, A comma B. Let us write a PDA. Let's see the solution now. First of all, as I said earlier, that the start state should be for the PDA is same as the start symbol of the CFG, that is A, that is your S. This one is the start symbol. Okay. Then your the state throughout in the PDA is Q. Okay. So let's start with Q now. So for Q, what are the transitions you can contain? Okay. First rule, Q comma epsilon for S, comma Q comma A, B, P. For the first rule I finish. We have other rule for S, so that I will write as a second rule. So Q comma epsilon comma S can give you Q comma A. Next we have the third rule for A, that is the next non-terminal, Q comma epsilon comma A, that can give you Q comma A, B, B. Next we have one more rule on A, that is Q comma epsilon comma A, which will give you A gives A. Here you have other rule. So Q comma A. Okay. Next we have one more rule on B. Two more rules on B. 5. I will write for this first. So Q comma epsilon comma B, that B is going to give you what? B, B, B. Then B is also giving you A, so that will write next. So 6 Q comma epsilon comma B is giving you Q comma A. What was the last rule? The last rule was C gives A. C gives A. So let me write for that as the seventh rule. Q gives epsilon comma C gives A. So Q gives Q comma A. Okay. So this was the last rule. C gives A. For that I wrote C gives A. Okay. Next, for the terminal symbols, how many terminal symbols we have? Here A and B. Only for that we have to write the transitions. PDA transition. So PDA transitions for A and B would be, that is all terminal symbol would be Q gives A comma A comma, this should be your 8th rule. A comma A is Q comma epsilon. Then the 9th rule is Q comma B is Q comma epsilon. This is how you can write the PDA transition. This is the PDA to CFG conversion.